Now, in this video, we will going to take up one more problem. The problem number 2. It reads as, determine the diameter of the solid shaft which will transmit 440 kilowatt at 280 RPM. If maximum torsional shear stress is to be limited to 40 Newton per mm square, assume G will be equal to 84 kilonewton per mm square. So the data what they have given, we will going to list it. So capital N, which is the power which is given by 440 kilowatt, and small n, which is given by 280 RPM, and the torsional shear stress or the maximum torsional shear stress is limited to 40 Newton per mm square. So tau will be equal to 40 Newton per mm square, and G, which is equal to 84 kilonewton per mm square. So convert that kilonewton into Newton, which will be equal to 84 into 10 to the power of 3 Newton per mm square. So what we need to calculate, so we know that the power transmitted by the shaft, which is capital N, is given by 2 pi N capital T by 60,000 kilowatt. So since it is given in kilowatt, so you can substitute directly. So substitute the value of capital N as 440, which will be equal to 2 pi into N, which is 280 RPM into 280 into capital T by 60,000. So on simplification, so the mean torque transmitted by the shaft, which is capital T, is given by, on cross multiplication, 440 into 60 into 1000 into 60 into 1000 divided by 2 pi into 280. On simplification, you will going to get it as 15 into 10 to the power of 3 Newton meter. So convert that into mm. So which is equal to 15 into 10 to the power of 3 into 10 to the power of 3. So that becomes 15 into 10 to the power of 6 Newton mm. So from the torsional equation, what we know is tau by R, which will be equal to G into theta by L, which will be equal to T by JP. So since here in this case he has given the we have calculated the torque, we know tau. We have to calculate the value of R and JP, which both will going to consider the diameter. So since I need to find out the diameter of the shaft, so we will consider T by JP will be equal to tau by R, which will be equal to tau into JP by R, which will be equal to tau into ZP, where Z or torque is given by pi d cube by 16 into tau for the diameter of the solid shaft. Since we know the torque, substitute the value of torque as 15 into 10 to the power of 6 will be equal to pi d cube into tau is 40 divided by 16. So on simplification, the diameter of the solid shaft, which will be equal to 124 mm. So this is how you will be able to calculate the diameter of the solid shaft. Thank you.